So today what we're going to do is start a new unit. The unit will be on parallelograms, but today what we'll be doing is we'll be doing systems of linear equations, which is where you have more than one equation that you need to solve. The reason we're doing that is because in this unit you'll have to be solving systems of linear equations. Many of you will remember this, some of you fondly, some of you not so fondly. Those of you who are doing Algebra 2 this year, you've already done this year. Did you do systems of three equations and three unknowns? And you used matrices probably also, all that kind of good stuff. We're not going to use a calculator to solve these. We're going to solve these by hand, but we're not going to do 3x3s or 4x4s or any of that nutty stuff like that. So, first of all, what is a system of linear equations? Well, it's a collection of first-degree polynomial equations. Like first-degree polynomial equations. That means that the exponent can be at most 1. That's the degree. No x squareds, no y cubes, none of that kind of stuff. Involving the same set of variables. In order to solve such a system, the number of equations must be equal to or greater than the number of variables. So if you have two variables, for us that's going to be just x and y, then you have to have at least two equations. We won't ever have more, but you could have more. If you had three unknowns, like an x and a y and a z, then you've got to have at least three equations. That's why it's sometimes called a 3x3 system. So the two methods that we're going to use are substitution and elimination. I will never direct you to use this method or that method. You can use whatever method you want, okay? But I'm going to point out to you that it's a lot faster and a lot easier to use one method sometimes than it is another method. So let's dive in to some examples. So we're going to solve each of these systems. On one like number 1, if a variable is already isolated, that is, it is all by itself on one side of the equation, it's almost always simplest to use substitution. What we'll do is take what that is equal to and substitute it in the place of that variable in the other equation. So here we'll have 3 times 5y minus 23 plus 4y is equal to 26. Now we have an equation in a single variable that should be relatively easy to solve. So that's going to be 15y minus 69 plus 4y is equal to 26. Let's see, I'm going to add 69 to both sides. So this is going to be 19y is equal to 95? Yeah. So then dividing by 19, we get y is equal to 5. Since y is equal to 5, we know then that x is equal to 5 times 5, replacing the y with 5, minus 23. So it's 25 minus 23 is 2. So our answer is always an ordered pair. Our solution is the ordered pair 2, 5. Straightforward enough? All right, everybody try the second one on your own, please. You're making a face. Why are you making a face? So you have to be really careful about keeping your negatives with this. Is that where it went wrong? Maybe. Losing a negative is the easiest mistake to make. It happens more often than just about any other mistake in all of mathematics.
So if there's like a negative 5 on the outside,
Uh-huh.
you would multiply 2x by negative 5 and multiply negative 11 by negative 5?
Correct.
Oh, I thought we were just multiplying by 5.
Well, if you do that, then you have to, let me show you. You can do that, but then you have to leave the minus sign and a set of parentheses or brackets. This would be 10x minus 55. And then when you distribute the negative sign or subtract, you can do that. I don't because, yeah, it's an extra step that I'd rather not have to do.
I don't really get that because it's like you're distributing negative 5. Doesn't that kind of imply that negative 5 and 2x are being multiplied?
You could think of it as 2x minus 5 times this.
Okay.
So you can think of it either way. I think it's just more efficient to think of it as I'm distributing the negative 5.
Right.
Oh, so that's literally it?
We're just going to practice and we're going to do some that are harder than others.
Oh.
And some where there's more than one right way to do them. Or more than one good way to do them. All right, so for example number 3, we have an example where the first equation is in or close to in what's called standard form, where you have something x plus something y equals a number. By the way, most textbooks will say in standard form the number in front of the x has to be positive. So you'd have to multiply all this by a negative to make it into what's called standard form. It's not a big deal right now for you guys. But the second one isn't close. In fact, the variables aren't with each other. So I'm going to actually subtract 2x from both sides, and I'm going to subtract 40y from both sides, because that will leave me with just x is equal to negative 12y. And then I'll substitute. So replacing the x with negative 12y, we have negative 2 times negative 12y plus 6y is equal to 15. So it'll be positive 24y plus 6y is 15. So 30y is 15, so y is a half. You will have some fractions on these. If you get something like 11 and 13/57ths, it's probably wrong. Because, well, although I'm the meanest person you're ever going to meet in your life, I'm not that mean. Okay. All right, so if y is a half, then x is negative 12 times a half, so x is negative 6. Now, you didn't have to do that one this way. If you don't want to do it another way, you don't need to, but let me just show you that we could have also subtracted the 2x and subtracted the 28y. And I would have had x plus 12y is equal to 0, right? At that point, I could do what's called elimination. I could have multiplied this equation by 2, and y2 because then I'd have 2x and a negative 2x. Or I could multiply the first equation by negative 2 because then I'd have a negative 12y and a positive 12y. Either way is fine. I'm going to multiply this equation by 2, so I've got 2x plus 24y is equal to 0, and negative 2x plus 6y is 15. The interesting thing is, if you do that, you end up at the same spot we ended up there. And the work continues as before. Is one of them easier? I think it's easier on this one to substitute. You don't have to do as much work. So on number 4, you can choose to substitute or you can choose to do it by elimination. I'm going to show you both. And this one for me, when I look at this, it's kind of a toss-up. It just depends on my mood at the moment which one I'm going to use, honestly. They're about the same, at least in my head. If I wanted to use substitution, I just need to take this equation and subtract 8x from both sides, and I have y equals 4 minus 8x. Then my other equation becomes 3x minus 5 times 4 minus 8x is 23. So that's 3x minus 20 plus, what is that, 40x is 23. This feels very wrong. Okay. Oh, then when I add 20 to both sides, I get 43x is equal to 43. Suddenly it feels very right. So x is 1, and y is 4 minus 8 times 1, so y is negative 4. So you can do substitution on this one if you want, because it's easy to isolate y. If it's easy to isolate a variable, substitution works quite nicely. It's also very easy to do this by elimination. If I take this bottom equation and multiply it by negative 5, leaving the top one alone, I have 3x minus 5y is 23. Oh, sorry, I don't need to multiply by negative, just by 5. And then I get 40x plus 5y is equal to 20. I get 43x is equal to 43. And again, we're back to where we were before. I think it's maybe slightly easier to do elimination on this, because it's maybe one less step.
But wouldn't you still have to isolate y and stuff?
Yeah, let's go ahead and continue this. You get x is equal to 1, and then you have to go, okay, 8 times 1 plus y is 4. So you do have to eventually isolate y. You don't have to do it symbolically. You can do it numerically. So there's kind of an extra step here. It's 6 of one, half a dozen of the other in my mind. Is that a phrase that anyone knows?
No, but it makes sense.
Well, there's that. You can kind of get it from context, and it's like, oh, 6 and half a dozen are the same thing. Okay, now let's take a look at some where I would absolutely not, unless you, I don't know, threatened me in some way, use substitution. why is substitution going to be so awful? Well, can I easily get x or y isolated without having fractions? No. So I'm absolutely not going to use substitution on one where I can't isolate a variable quickly and easily. But this one, it's really easy to eliminate the x, right? Simply multiply the first equation by -2. By the way, the most common mistake on these, other than losing the negative sign, is forgetting to distribute all the way through the equation. People will multiply the first two parts by a number and then forget to multiply the last part by a number. So this is going to be -8x.
Why do you do -2 again?
So this will give me a -8x here, so that when I combine it with the positive 8x, they drop out. That's the goal of elimination, is to have one coefficient on a variable be the exact opposite of the coefficient in the other equation. You want a -8 and a +8, or a -17 and a +17. So I've got -8x minus 10y equals -60, and I've got +8x minus 3y is equal to 8. So that when I combine these two, sometimes this is called linear combination. It's the same thing. When I combine these two, I get -13y is equal to -52? Divide by -13 and I get y is 4. Once you've done that, elimination problems always have an element of substitution in them, because you've got to substitute now, right? And it doesn't matter which equation you substitute back in. I guess maybe I tend to do it into the one that has smaller numbers or fewer negatives, but I don't spend a lot of time thinking about it. I just kind of go, okay. So does someone have a preference on which one?
8x minus 3y equals 8.
Okay. So 8x, and by the way, that's the one I would have substituted it into. I don't know why. It just feels better. Pardon?
I think it's like the y value will be smaller.
Oh, right. And then you don't have as big a number here, and you're going to add something instead of subtracting. So in some ways, it's just nicer. So it's going to be 8x is equal to 20. So x is what, 2.5? So my answer, be sure to write your answer as an ordered pair, is 2.5, 4. Any questions about that? In some problems, you're not going to be able to just multiply one equation by a value. You're going to have to multiply both equations by some value. Take number 6, for example. First of all, I always check, is there a way I can do substitution? And I immediately go, no, that's not going to be nice. Because I'm having to divide everything by 5 in this one, or by 2, and that's not going to be good. 3 sort of starts off nice, but now I've got 2/3 x. Ugh. All right, I'd like to avoid the fractions until the end of the problem. For this one, you have lots of choices. You can eliminate the x, you can eliminate the y. Which one should you eliminate? It doesn't matter. Which one do I eliminate? The one with the smaller coefficients. You know, if this is my salary, I want the numbers to be bigger. Other than that, I want numbers to be small. Okay? So I'm going to multiply the top one by 2 and the bottom one by -3. So that I end up with a 6y and a -6y. I could have done -2 and +3. I chose a negative just to get rid of this negative. I'm still going to have a negative. It's impossible to get rid of entirely. So this is 4x plus 6y is 30. This is -15x minus 6y is equal to 3. Add those together and I get -11x, don't lose that, is 33. Divide both sides by -11 and we get that x is -3. Doesn't matter a whole lot. I'm going to substitute it into the first one. So 2 times -3 plus 3y is 15. That's going to be a -6. I don't take the time to write the -6 plus 3y. I just go ahead and add 6 to both sides. So that'd be 3y is 21. So y is 7. Let's do one more and then I'll let you get started on your worksheet for tonight. Don't be too happy. It's kind of lengthy.
It's fine. Anything's better than that, than the book.
Than the book? Okay. Here, since one of the x's is negative already and one of the other x is positive, I would eliminate the x. And I could multiply the top one by 6 and the bottom one by 4. But if you think just a little bit, I'm like, okay, I can multiply by 3 and by 2 and get a common coefficient. So I multiply this by 3 and this by 2. And that's -12x plus 9y is 30. And 12x plus 10y is 8. Combine the two equations, we get 19y is 38. So y is 2. I'll substitute into the bottom equation. It doesn't have any negatives in it. So that'd be 6x plus 5 times 2 is 4. Subtracting 10 from both sides gives me 6x is equal to -6. So x is -1. So my solution is the ordered pair -1, 2. Okay, any questions about that? Okay.